Hi, this is Mono. So today I'm going to talk about the final project. Uh, so let's get started. So we have the first set of problems with probability. Here we are asked to actually create two variables, x and y. One of them is from 1 to n with random number till 10,000. The other one is the mu, the mean, and the standard deviation. I'm sorry, and the formula that you have here, n plus 1 divided by 2. So this particular data frame will contain two columns filled with those random variables. And here is the mean, 5.506 and 5.504 x and y respectively. So the questions we are asked to actually initialize x as a median, which also could mean that it is 50th percentile, or just could call it a median function. And the first quartile, that's the first 25%. So we have the results here, and then based on that, we have to solve a few questions. Probability of A, given that B has occurred. So we have the values here, obviously, and then we run this function, and then we find that the probability is 0.551 approximately. And the second question is probability of A being greater than B. Again, we run the similar function with different inputs here. Here, and then you get 0.3808. And similarly, probability of A given that B has occurred would be 0.4487. So the question 2 is creating a table and investigating if the probability of A and B is equal to probability of the product of these two probabilities. So we create a group, mutate, and summarize, and do a whole bunch of things to create tables. So this table gives you columns giving you the probability. So the first probability is given A and B, that is 0.3808. That is this one here. And the second one is product probability A and B. That is 0.5, this one, and this one. So we multiply, find the product of that. And obviously we find that 0.38 is different from 0.37. So they are not the same. That's the conclusion. And then we have a few tests. The Fisher exact test and the Chia squared test. The main difference between both of them are the Fisher test can be run with small amount of data, smallest data size, the cell size is small, and the Chi square is used for larger one. So obviously this data set is large. In my opinion, the Chi square is the most appropriate one. So moving on, we have problem number 3. So problem number 3 is very, very interesting because this gets you as close as to the real life as possible when you're dealing with data science. So this is real life problem that you would face. So here we had to go to Kaggle and do one of the models and submit it. So here we have a training set and test set already on Kaggle, which is great. So the first thing usually in any real life scenario is getting the data and finding NA values or outliers, extreme values and stuff like that, and then smooth it. Data smoothing is the most important one. Here, I chose to replace NA with 0. We don't have to do that. In real life, we could do an average or average based on certain category, like grades of employees or whatever. You could do that to smooth the data. Whatever. So basically, you have to go inside, probe the data, and test each column, and see what makes sense. So question number 1 is descriptive statistics. Obviously, when you get data, first there are a few things that you would like to test: the minimum, the quartile, the median, max, and things like that, and then standard deviation. What kind of data it is? You could do it visually or reading the numbers. Here is a visual representation of the type of data. Obviously, it's kind of normalized here, or it could be exponential or whatever type we have. And then we have scatter plot. This is the matrix of the scatter plot, which is easy to see. So here, if you take a look, the one here, the sales price and the living area, looks more like there's a linear relationship here. I would select this as one of the feature. So for this one here, the basement and year build, it doesn't look like there's a relationship, but I still would go investigate, and probably all that you need to do is do a transformation to get more linear functions lines there. It could be a logarithmic function or something like that. We just have to play around with data. This is individual plot for lot area and size. If you want to go deep into the data. There's another one. The correlation matrix. It is simply it tells you simply the correlation between different variables, 2 variables or more. Here we did we selected few columns here, and obviously this is a visual representation of the matrix itself, and we can find what columns are more likely to be correlated and have relationship. So we could take that as one of the feature or not, if depends on the analysis. This is more histogram kind of visual representation with numbers. So if you are interested in this kind of correlation matrix. So the next thing we do is hypothesis testing. So there are different kinds of testing, but the default is a Pearson correlation. So obviously for that to happen, you need to have certain assumptions, like it should be normality of variables, linearity, and things like that. There should be absence of outliers. The few things that need to happen for that to work. You could also use other rank-based correlation models, but then you have to specify in this input here. Okay, so the important values here are the degree of freedom. The p-value should be less than 0.05 to have a relationship. And then obviously we have a Pearson correlation number here, which is 0.26988. So this is for other variable. So I found that since the p-value is great, I thought there is less correlation between the numbers, variables. And this is Pearson matrix. It's nothing but the inverse of the covariant matrix. So if you multiply here, we're multiplying both of them. Obviously, if you multiply, you get a identity matrix, and if you multiply them, you still get an identity matrix. And this is the LU decomposition and the correlation matrix. here we have um, the variables q to the right. So here, this is interesting. Fit. So maximum likelihood fitting. So you can take your data and fit on the type of distribution. For example, you can take a data and make it normal or exponential or gamma or whatever you want. You just have to specify it here and do analysis on that. And then you can find optimal value and things like that. This is a histogram of exponential data, and this is the original data here. And these are the percentiles, 0.505 and 95 percentile. Confidence interval, obviously, it tells you that where the data lies in the population mean. Is it close to the mean, away from the mean, and things like that. So yeah, here is an example of getting for 95% confidence index. Moving on. Okay, so the actual model. So we took the training set and ran linear regression here for the dependent variable of sales price and independent variables. There are four of them here. So we ran against that, and then reading this. Usually, if you have 3 stars here, it's more correlated. There's more correlation there. Okay, so this is a visual representation of the plots. So it's easy to look at in one shot. We smooth the data further, and we ran the test and submitted. The score that I got for me was 0.56. Obviously, it could be better. Yeah, and my username is down there. I hope this was I explained it enough, and I enjoyed this course and learned a lot. Thank you.